1. So if I see, what's n equals 10? What would that be?
5/7.
Yeah, so 10 over 14, 5/7. And you can see directly, at 3 we're at 3/7, at 10 we're at 5/7. Right? So it does look like it's, now that's not a proof. You can never prove anything by just showing a few examples, but it verifies what we know from that proof. It's going to go to 1. Cool. Okay. How are we doing so far? I mean, I want you to realize how much of this stuff you already know. You've already talked about a lot of this stuff, just you haven't used the symbols we're going to use. And then, of course, we're going to talk about new shit after that, stuff you've never talked about before. But we already know a lot of this stuff. Okay. So let's see real quick. Let me keep myself in order here. Yeah, not that. What if you had something like this here? Let me start giving us some terminology and symbols. Let me tighten this up a little bit. AN is the nth term of a sequence. So for example, I could have written this as AN equals n over n plus 4. Now that's a little lacking, honestly, because where does n start? It doesn't always start at 1. Normally it starts at 0 or 1, but it could actually start wherever the hell I want it to start. So that doesn't really give me a place to tell people where I have to do it on the side. So another way to refer to a sequence is put them in braces and brackets. And then out here you can say n equals 1 to infinity, right? Now that looks a lot like integration. Is that all right? Cool. So I could say, again, I could say, for example, just put this in here. N equals 1 to infinity. So let me have you guys write out the first 5 terms of this sequence here. Yeah. There's nothing in there you haven't seen before, right? Everybody understands what that is. It doesn't say negative 1 n plus 1 over n squared over n plus 2! What does that mean, that symbol?
That you really want us to do.
What's that symbol mean? You guys, maybe I should take a second to make sure. It's a factorial. Who here, honestly, has never really worked with a factorial before? I would hope that all of you have. It's okay if you have. So just to remind you guys, what would 7 factorial be? 7 times 6 times 5, blah, blah, blah.
Okay.
All the way down to 1, right? So what's like n plus 8 factorial? N plus 8 times n plus 7 times n plus 6, blah, all the way to 1. How many terms are there here? It depends on what the hell n is, right? If n is negative 7, there's 1 term, really, because it starts off at 1, right? If n is 20, that's 28 factorial, 28, 27, 26. But you always, the next one is just 1 minus where you start. That's the idea of factorial. All the way down to 1, you multiply them out. Bam. Right? So try to write out the first 5 terms of that sequence. This is just a plug and chug. for A1?
1 6.
1 6, I love it, because you plug 1 in, 1 squared. Negative 1 to the second power is positive 1. 3 factorial is 3 times 2 times 1, 6. Sweet. A2.
Negative 1 6.
Yeah, so now you get a negative from this guy. So every other one's going to be negative. So basically, anytime you see something like this in a sequence, it's going to alternate the sign. So you get negative.
1 6.
Cool, so there'll be 4 over 4 factorial. The 4's cancel. So you're back to 1 6. Yeah.
For the second, when we do the second term, we do for the bottom, for the factorial, we do 2 plus 2 and then times 1 plus 2.
So here it would be 2 plus 2 factorial, right? So it'll be negative 4. 4 factorial will be 4 times 3 times 2 times 1. That's what a factorial is. That tells you where to start, and you multiply it by the next one down, the next one down, the next one down, until you get to 1.
So you eliminate it. Okay.
Cool. So the 4's cancel, and then back to negative 1 6. A3. So now I got a positive guy again, negative 1 to the 4th power. 3 squared is 9. 3 plus 2 factorial, so it'll be 5 factorial. That goes into 9 3 times. So I got 3 over 40. Sweet. And same thing, I mean, so now every other one is negative. N squared, so 4 now, so 16. 4 plus 2 is 6, so 6 times 5 times 4 times 3 times 2 times 1. Alright? How we doing? 8 goes into 16 twice, 2 goes into 6 3 times, so I get negative 1 over 45. How we doing? I mean, this is not bad, this is not hard at all, just plug and chug. And A5, what do you guys get for A5? Let's cut to the chase. Do you guys do A5 yet? No? Okay. 25 over 7 times 6 times 5 times 4 times 3 times 2. So 5 goes in 25 5 times. And whatever the hell all that crap is. Let's see. 42, 84 times 12 is 40, 68. Let's see. Oh, I can't think of it.
5 over 110, 1,008.
1,008? 8? No. No, yeah, you're right. Yeah, 860 plus 148.
Calculator.
Yeah, okay. So 5 over 1,008. Okay, cool. All right, so one level of this is pretty damn easy. So you can expect that most of your problems won't really deal with this too much because that's pretty damn easy. I mean, you can create the terms of a sequence easily enough. So we're going to talk about kind of more expansive concepts. It's pretty easy possibly to tell. Do you see how it does alternate? Positive, negative, positive, negative. But what can you say? What do you think is going to happen if I let n get really big?
It'll go to 0.
It's going to go to 0. It's going to attack 0 from 2 different sides, right? It's like, I'm over here, and I'm over here, and I'm over here. But it's always getting closer and closer, right? Like some weird X-Man thing. Transporting dude. No? Okay. All right. So here's where things get a little bit more difficult. And we're not going to get really deep into this, but I need you to know how to do something like this here. Let's start off nice. Why not? Can you guys come up with that for this? So take a second, don't say anything out loud. Do you guys understand what I'm saying? I want you to come up with what this must have been to give me those elements. So when n is 1, I want to have this. When n is 2, I want to have this. Oh,
it,
you got it?
yeah.
All right, so
Is it 2 plus n? Oh, wait. Oh, never mind. There's a negative.
so how do you take care of the alternating negative?
Put a negative 1 to the n plus 1.
And you want the first one to be positive. So if you're calling that n equals 1, you're right. You want it to be, no, you're fine. Because then if n is 1, that'll make a negative 1 squared, which will be positive, right? Okay. And then the bottom's easy. Let's worry about the top in a second, but the bottom's easy, right? 5 to the first, 5 squared, so it's just 5 to the n. No big deal. And this is, if n equals 1, it's 3. If n equals 2, it's 4. The negatives, I don't care about. I've taken care of them, right? So I can not worry about them now.
2 plus n.
It's always 2 more than whatever term I'm at, right? So it's going to be just n plus 2, yeah. I love it. Or 2 plus n. Now, can you guys give me an idea? Looking at the sequence itself, you would want to say that it's definitely going to, is it going to converge or diverge? Does it approach a number or does it not? Does it go to infinity? Does it approach a number? Maybe I'm saying that
It goes to 0.
Is what?
it's going to have to be going to 0, right? Isn't that what it looks like? Now, you've got to be really careful. Some of my colleagues kind of say, and I don't mind writing a few elements of a sequence out, but you can never tell anything directly just from that. Because maybe after the 4th element, it starts to go up again, depending on what the function is, right? Now, obviously, this function is pretty straightforward. It's pretty simple. You can tell it's going to do, it's very single-minded.